Hello again. In this third video for rational expressions, we talk about how to add and subtract rational expressions. The thing to do is to recall what you did with fractions. You'll remember that there were two types of fractions when you're talking addition and subtraction of fractions. There are like fractions and unlike fractions. For example, you learn to add things like 4/7 and 1/7. So how do you add 4/7 to 1/7? Because they are like fractions, and like fractions are fractions that have the same denominators. So these fractions have the same denominators. All you had to do was just add the numerators together and retain the common denominator. So 4/7 plus 1/7 will be 5/7 because 4 plus 1 is 5. Or 9/10 minus 5/10. Again, these are like fractions because they have the same denominators. So all you had to do there was just combine the numerators, which is 9 minus 5, and your result is 4. So 4/10. And since 4 and 10 have a common factor of 2, you can divide 4 by 2 and divide 10 by 2 to get 2/5. So 4/10 is the same thing as 2/5. You would say that is in lowest terms. So generally, when you add or subtract fractions, you want to reduce to lowest terms. So the same thing you do with rational expressions. When you add and subtract them, you want to reduce to lowest terms by factoring and then taking out the common factors. Similarly, you learn about unlike fractions, which were fractions that do not have the same denominators. They have different denominators. For example, 1/5 and 2/3. You can see that the denominator for one is 5, the denominator of the other one is 3. So what you learn to do is that you learn to find the least common multiple of the denominators. And then once you found the least common multiple of the denominators, we will rewrite the fractions to have the least common multiple as a new denominator. So they will be like fractions, and the denominator will be the least common multiple of 5 and 3. But first of all, let's recall what least common multiple means. Well, all that means is to write down the multiples of the numbers. So multiples of 5 and multiples of 3 as shown. Multiples of 5, 5, 10, 15, 20, and so on. And the multiples of 3, 3, 6, 9, 12, 15, and so on. And you don't have to write too many of them. You just need to write so that you see some common ones there. And you can see that there are a couple of common multiples there, 15 and 30. And then we choose the lowest of these common multiples, which is 15 in this case. So once we realize this least common multiple, we'll then rewrite the fraction. Now, I'd like to show you a little bit of a shortcut here, how to find the least common multiple of two numbers. The least common multiple of any two numbers is the product of those two numbers divided by the greatest common factor of the two numbers. So in this instance, for example, the least common multiple of 5 and 3 is 5 times 3 divided by 1, because 1 is the greatest common factor of 5 and 3. So you can do that pretty much with anything, and I'm going to I show you how to do that later on. In the subsequent examples, I will demonstrate that as well. So now we can rewrite our fraction, or our original fraction, 1/5 plus 2/3, to have a denominator of 15. Each of the components will have a denominator of 15. Now what we then do is to figure out how to what we use to multiply, or what we can use to multiply 5, the denominator for 1/5, to get 15. So you will see that if you multiply 5 by 3, you will get 15, and then you multiply the numerator as well with the same number. So we'll multiply 1 by 3 to get 3. We'll multiply 5 by 3 to get 15. Similarly, if you multiply 3 by 5, you will get 15 for the second fraction, which is 2/3. And then you multiply the numerator also by 5. Okay, 5 times 2 is 10. So therefore, our fraction 1/5 plus 2/3 is the same thing as 3/15 plus 10/15. They are now like fractions, and all we have to do is add the numerator and retain the common denominator. Our result there is 13/15. And these are in lowest terms because there are no common factors greater than 2 in there, so there's no need to reduce this, already in lowest terms. So now let's switch now to why we took a quick look at how to add fractions. We are dealing with addition and subtraction of rational expressions. So let's start with these ones. 4 over y minus 1 over y. Well, these are like fractions, like they have a common denominator, so all you have to do there is just combine the numerators. 4 minus 1 is 3, and the result is 3 over y. Like we had done previously, the restriction here is y is different from 0. You cannot have 0 in the denominator. Another example, 3 over x plus 4 plus 7 over x plus 4. Again, these are like fractions. You can see that the denominators are the same. So all you have to do is combine the numerators and you will get 10 over x plus 4. Your restriction is x is different from -4. Let's look at one that's not like fractions. So 6 over 5x plus 9 over 2x. So this one is like having two unlike fractions. Like we did previously, we are going to find the least common multiple of 5x and 2x. So that shortcut I showed you previously, I'm going to use it now. The least common multiple of 5x and 2x is 5x times 2x divided by the greatest common factor of 5x and 2x. The greatest common factor is x. So if you simplify this, you will get 10x squared divided by x, and your result will be 10 times x. So therefore, the least common multiple of these two is 10 times x. We can then change the denominators. We are going to rewrite these two fractions. We are going to write equivalent fractions so that the denominator for each one is 10x. So how do you go from 5x to 10x? What do you use to multiply? It's 2. If you multiply 5x by 2, you will get 10x. So therefore, we'll multiply the numerator of 6 over 5x, which is 6. We'll multiply that numerator by 2, and we'll get 12. Similarly, to go from 2x to 10x, you have to multiply by 5. So therefore, we'll multiply the numerator 9 by 5 as well. And now we have our original expression, 6 over 5x plus 9 over 2x, is now the same thing as 12 over 10x plus 45 over 10x. They are now like fractions. We'll simply combine the numerators and we will get 57 over 10x. These are in reduced form. There is no common factor there, and our restriction is x is different from 0. Let's do another one. M over 8n plus 3 over 10n. Again, these are unlike fractions. We'll have to find the least common multiple of 8n and 10n using our shortcut that I talked about before. The least common multiple there will be 8n times 10n divided by the greatest common factor of 8n and 10n, which is 2n. Right? So if you simplify this, you will get 40n. And then we'll have to rewrite the denominators to have 40n. So how do you go from 8n to 40n? You multiply by 5. So then you have to multiply the numerator by 5 as well. You will have 5m over 40n. And similarly for the second rational expression, if you multiply 10n by 4, you get 40n. And so you multiply the numerator by 4 as well. So now you have like fractions. You can just combine the numerators. You have 5m plus 12 divided by 40n. Your restriction is n cannot be 0. This is in reduced form. You cannot have any, there's no common factor there that you can take out. One more example. Let's do 2p over 3p plus 3 plus 5p over 2p plus 2. These are also unlike fractions. I hope you can see that. But one of the things to do first here is to factor the denominators, right? If you have binomials in the numerators as well, you may like to factor it first. But in this instance, if we factor this, we've learned how to factor now. This expression is the same thing as shown, 2p over 3 times p plus 1, because the greatest common factor of 3p and 3 is 3. And similarly, 5p over 2 times p plus 1. You can see that those denominators are not the same, so we have to find the greatest common factor, the least common multiple of these denominators, which in this case, the least common multiple, if you multiply and divide by the greatest common factor, the least common multiple will be 6 times p plus 1, which you can then write, use the denominators, you rewrite them, and you will obtain equivalent rational expressions as shown with the new denominator, which is the least common multiple of the previous denominators. And then you can just combine the numerators, 4p plus 15 divided by 6 times p plus 1. Your restriction here is p cannot be -1. So you go ahead now and try your hand on this example like we had discussed previously. Please, you can pause the video now, and then after you're done, you can continue the video to see what I have done. Okay, so what did you do? So I'll show you what I did here. For the first one, those are like fractions. All you have to do is just combine the numerators, retain the common denominator, and then you can state your restriction. For the second one, Again, they are like fractions. All you have to do is combine the numerators. But in combining the numerator, you can see that the numerator for the second fraction, for the second rational expression, is a binomial, right? So you have to be careful there that the minus, you are subtracting the entire numerator. That's why I have brackets in there. If you open up those brackets and collect like terms, you will have negative 2x minus 4, and you can factor the numerator. There's a negative 2 as a common factor there. Your restriction is that x cannot be negative 3/2. And thirdly, the last one is that they are unlike fractions. So you would have to factor the binomial for the denominator for the second rational expression, and then write the least common multiple, which will be 3 times y minus 2 is the least common multiple if you think about that. And then if you can subtract as shown in the previous example, because they are now like fractions, and your result will be 5y minus 1 divided by 3 times y plus 2 with a restriction of negative 2. So y cannot be negative 2. So that concludes our video on the topic rational expressions.